Hello grade 5 and happy Friday. Hope that everyone has had a good week so far. We have another lesson today. We are on to NS5-39 and that is dealing with equivalent fractions. So we've already had some time obviously with fractions, and we've been comparing fractions, putting them in order, that kind of thing. This is going to be a little bit different because now we're taking a look at equivalent fractions. So we've been talking about less than, greater than. We've had some equal to, but so that's what we're going to be dealing with today, are all fractions that are equal to one another. Equivalent, equal. You see, that's kind of the same root word as we have in equal. So when you think about equivalent fractions, think of a fraction that is equal to the other fraction. So let's take a look at this first example. And it says here, a parent and a child were sharing a cake. So the parent divided it into two pieces. So we'll pretend this square here is the cake. Two pieces. The child said he wanted two pieces, so the parent cut the cake again. So if we're looking at the white spot and saying that's what the parent got, the unshaded part, and then we'll say the child got the shaded part. So if you notice now we cut it into two pieces. And ask the question, did the child get more cake by getting two pieces? And if you look and compare the area that's shaded, you will know that no, the child did not get more cake by getting two pieces. Remember what we talked about in the last lesson, how if you divide it into more pieces, the same part, then each piece is going to be a little bit smaller. So if you divide it in half again, now you've got two pieces, but it's going to be equivalent. It's the same. And just to give you what that fraction would look like, we've got two spots, so that's our denominator, so 1/2. And here we've got 1, 2, 3, 4. So 4 is our denominator, and then 2 shaded, so 2/4. So 1/2 would be equal to 2/4. Just to give you a little thing to look about, to think about, if you notice the relationship between the numerator and the denominator, we've multiplied it by 2. So 1 times 2 is 2, 2 times 2 is 4. And we'll get into it a little bit later in the lesson, but you can keep doing that. And if you keep multiplying the numerator and the denominator, and you have to make sure you do it to both, you can keep coming up with new equivalent fractions. So that's just a quick little introduction to that. Second example here, these fractions are equivalent because the pictures have the same amount shaded. So 1/2 equals 2/4. Kind of what I was just saying in that last example, just another, just to reiterate that point. So just give me 1 second, I'll pull this part down. And you look at here, both people get twice as many pieces, but the same amount of cake as before, because the amount shaded versus unshaded remains the same, just different sizes of pieces, but that doesn't mean that the total amount is any different. All right, so let's take a look at these exercises. And it says, copy the picture into your notebook, break each part in half to create equivalent fractions. And I'll show you what these fractions look like. If you have a piece of paper and can do this at home, excellent. If not, just take a look at what I'm doing and hopefully that'll help you see it. So if we look at this first fraction, we've got 3 parts, 1 shaded. So 1/3 would be what we have initially. Then if we divide it in half, we'll say that's approximately half. And I'm just going to put an equal sign to show that these are equivalent fractions. So then I can just count my spots, or my spaces. So 1, 2, 3, 4, 5, 6, and 2. So 1/3 equals 2/6. Okay. And again, notice that relationship. If I multiply these both by 2, that's a way to get the equivalent fraction. So here, the next one, we still have 3 total parts. So 2 are shaded, so 2/3. Then if I'm going to divide this, now 6 again, but now I've got 4 parts shaded. So 4/6. And notice, multiplying by 2. And because I am breaking each part in half, in essence, I am multiplying it by 2. So 2 times 2 is 4, 3 times 2 is 6. Letter C. Now we've got 4 sections, so we've got fourths. 1 is shaded, so 1/4. And then if I divide that in half, I'm not even going to count this time. I'm just going to multiply because I know I'm dividing it in half. I know I'm then multiplying the amount of pieces times 2, and I'm going to be multiplying the amount of shaded pieces by 2. So if I multiply these both by 2, 1 times 2 is 2, and 4 times 2 is 8. So 1/4 equals 2/8. And I'll do the same thing here for D. I'll first figure out what the fraction, 1, 2, 3, 4, so there's my denominator. There are 3 pieces shaded, so 3/4. And that's going to equal, if I divide that by 2, I'm just going to multiply my numerator and denominator. Now remember, when you're doing this, whatever you do to the numerator, you have to do the exact same thing to the denominator. So for multiplying by 2, we multiply both of them by 2. So 2 times 3 equals 6. 4 times 2 equals 8. So 3/4 equals 6/8. So hopefully that's not too confusing there. And so you can figure out how to get equivalent fractions. You will have examples like that on your worksheet for today. And let's take a look here at the next example. And this is, again, something that you will see on your worksheet. So it says, how many times as many parts does the first picture have as compared to the second picture? So let's take a look at example A. So it wants to know, how many times are we multiplying it by? So here we've got 2 parts. Now here we've got 1, 2, 3, 4, 5, 6, 7, 8. So that means 2 compared to 8. 2 times what equals 8? Think about that. If you think about that, 2 times 4 equals 8. So there are 4 times as many parts. So that's what these questions mean. So you're just saying, okay, if it's 2 parts and then moves to 8, so 2 times what is going to get you to 8? So let's look at B here. Now I've got 3 in my original one. And I got 1, 2, 3, 4, 5, 6. So 3 times what equals 6? 3 times 2 equals 6. So this one would be 2 times. And just write a 6 there. And same thing then again is going to be for C. We've got 2 parts. Then we go 1, 2, 3, 4, 5, 6. 2 times what equals 6? 2 times 3 equals 6. So that's 3 times as many more parts. And then finally, for example, D. I've started with 1, 2, 3. Now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, I'm just thinking in my head, because it's asking me how many times more spaces are there. So 3 times what equals 12? 3 times 4 equals 12. So this one would be 4 times. There are 4 times as many parts in that first picture than in the second picture. So when you get to your exercise today, that's all that's asking you to do, is to figure out what the difference is. And if you notice, and if you think too about the inverse of multiplication being division, you notice 6 divided by 3, 2. 6 divided by 2 is 3. And 12 divided by 3 is 4. So that's just another way. If that works better in your brain to do it that way, perfect. But whichever way leads you to that answer, whatever works for you is great. Okay, let's go on to the next slide here. And I'm just going to do a color, because this is the same thing, but it's now asking for how many times as many shaded parts are in. So now we just need to worry about counting the shaded parts, not all the parts, just the shaded parts. And again, you'll have questions like this on your exercise. So here I've got 1 shaded part. Here I've got 1, 2, 3, 4. So that's going to be 4 times, because 1 times 4 equals 4. And remember, if you're thinking of that inverse operation, you can do 4 divided by 1 equals 4. Will give you the correct answer. So let's look at B here. I've got 1 and I've got 2. That one's pretty easy. 2. So 2 times as many shaded parts. And example C. All right, so I've got 1 here, and here I've got 3. So since we're dealing with 1, makes it pretty easy. So we're going from 1 to 3, so that's 3 times as many. And then finally, in example D here, now I've got 2. And let's see, 1, 2, 3, 4, 5, 6, 7, 8. So I can say 2 times what equals 8. Another way that we can say that is 8 divided by 2 equals 4. So therefore, 4 times. There's 4 times as many shaded parts in this rectangle than in that rectangle. Hopefully that's fairly clear for everyone at home. All right. We've only got a few more slides left to do. Now it's asking us to write equivalent fractions for the pictures. So hopefully you all remember how to write those fractions. We count the total number of parts. That's our denominator. Then how many parts are shaded. That is our numerator. So I'll look at the first one. I see 1, 2, 3, 4, 5, 6, 7, 8. So 8 is going to be my denominator. There are 4 parts shaded, so 4/8. Here, we've got 1 out of 2, so 1/2. Next one, I've got 1, 2, 3, 4, 5, 6, and 2 shaded, so 2/6. Here, I have, and I'm just going to write an equal sign, just to remember, because we're dealing with equivalent fractions, fractions that are equal. So 2/6 equals 3 parts altogether with 1 shaded, so 2/6 equals 1/3. Here we have got 3/6 again. 1, 2, 3, 4, 5, 6. 3 are shaded, so 3/6 equals 1/2. And for the next one, D, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm dividing this rectangle into 12ths. So 12 is my denominator. There are 8 parts of that shaded, so 8/12. And here I've got 1, 2, 3. So that equals 2/3. If you notice these relationships, 2 times 4 equals 8. 3 times 4 equals 12. Here, 1 times 2 equals 2. 3 times 2 equals 6. 2 times 3 equals 6. 1 times 3 equals 3. And here 2 times 4 equals 8. 1 times 4 equals 4. So that multiplication relationship is always going to hold true. Whatever you multiply the numerator by, you're multiplying the denominator by. It's very important, or you're not going to be getting the right answers when you're making equivalent fractions. And you will be asked sometimes to make equivalent fractions without seeing pictures like this. So that is a way that you can do it, multiplying. But you've got to make sure that you multiply both the numerator and the denominator by the same number. Oops. All right. So let's go on to slide number 8. You can use the same picture to show 2 fractions. So this is saying you can look at the big parts and the small parts. So if you notice the way this is divided up, there's some dashed lines and some solid lines. So I'll first look at just the solid lines. So I'm looking at like this part right here. So I see there are 3 parts. So that's going to be my denominator. Then if I'm just looking at those whole parts, 2 of them are shaded, so 2/3. Now if I want to look at the smaller parts, I can go 1, 2, 3, 4. 4 times 3 is 12, so it's divided into 12ths. And then there is going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 twelfths shaded. And again, notice that relationship. 2 times 4 equals 8. 3 times 4 equals 12. So that is a way, just if you have a picture with dashed lines, that you can make 2 different fractions with the same picture. Okay, slide 9. So it wants to write 2 equivalent fractions for the picture. And again, I'll look at solid lines, then I'll look at the dashed lines. So if I look at the solid lines, we've got 3 parts. So we've got a denominator of 3. One of those is shaded, so 1/3 equals, then if I include the dashed, I've got 6 and 2, so 2/6. Look at that multiplication relationship again. So 1/3 equals 2/6. All right, next one. 1, 2, 3. Again, 1/3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. And 1, 2, 3, 3/9. So 1/3 equals 3/9. Notice I've multiplied both the numerator and denominator by 3 here. This one, there might be a little bit more counting, but that's okay. We know how to count. So looking at just the sections with the solid lines, I've got 1, 2, 3, 4, 5. So we've got fifths. And then there are 1, 2, 3. So 3/5 is going to equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's going to be my denominator, 15. And I've got 3, 6, 9, so 9/15. So 3/5 equals 9/15. Notice 3 times 3 equals 9, 5 times 3 equals 15. So that multiplication shows you how you can get the equivalent fractions. You're doing the same thing to the numerator as you do to the denominator. Okay, I think we still have 3 more slides, but we're almost done, I promise. Okay, so this one asks, how many parts do I have to break each piece into to get 12 parts all together? So here is where you are going to look at that relationship and the multiplication. So 3 times what equals 12? 3 times 4, so you're going to have to break this up into each one into 4 parts. So if you count that there, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, did I not? Oh, because I only broke it up into 3 parts. Let me try that again. I said the right thing, but then I drew it wrong. There we go. So now I've got each section into 4 parts like I had said the first time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you notice then, you can count the shaded parts. 1, 2, 3, 4, 5, 6, 7, 8. So 2/3 equals 8/12. And so we multiplied both those by 4. So if you're asked to do something like that, that's how you can figure out how many more parts you have to break that fraction into. Okay, and next one. Now it's asking us to use multiplication to find the missing numerator. So we've got the denominators. So when we look at a problem like this, 1/5 equals something over 20, so something 20ths. Now, if we look at that, I need to say 5 times what equals 20? I can also say 20 divided by 5 equals 4. So that lets me know I'm going to need to multiply this by 4. That's going to be 4/20ths. Here, 4 to 16, I've multiplied by 4. So 3 times 4 is 12. 3/4 equals 12/16. 9 to 18, that's 2 times. So 5 times 2 is 10. 5/9 equals 10/18. And then last one here, 10 times 10 equals 100. So I'm going to take my 7, multiply that by 10 as well, and get 70. So 7/10 equals 71/100. You notice whatever you do to the denominator, you need to do to the numerator as well. Okay, and this is our last slide, so hopefully you're getting a pretty good grasp of this and we'll be able to work on those exercises at home. And this is just telling you just another way that you can skip count to create equivalent fractions. So you just keep multiplying times 2, times 3, times 4, times 5. And if you do that to both numerator and denominator, you can keep creating new equivalent fractions. So 3/5 equals 6/10 equals 9/15 equals 12/20 equals 15/25. Let's say I did times 6 would be 18/30. If I did it times 7, it would be 21/35, etc., so on. So you can keep, anytime if you're asked to create an equivalent fraction, multiply the numerator and denominator by the same number, and that will give you an equivalent fraction every single time. All right, well, I hope everyone has a pretty good grasp of that. If you have questions, you can let me know. But if not, good luck with your worksheet for this. I hope everyone has had a good week. I hope that everyone is enjoying the time with their family, and I hope that you all have a wonderful, wonderful weekend. Try to get outside and enjoy this beautiful spring weather. All right, well, I will see you all next week. Have a wonderful day. Bye-bye.